Things up a little bit, and that's going to require that we do first order linear. Okay, so let's go back to the tank. Let's set up a tank situation. So here's your tank. Let's say we got 5,000 liters this time. Let's have pure water this time, and we'll have some stuff coming in. Let's say it's coming in at 10 liters a minute, and let's say it's coming in at 0.2 kilograms per minute of something. What do you want in your salt? Could be salt, could be some chemical that's going to dissolve and mix. So kilograms per minute. Okay, let's say it's salt coming in. Okay. So let's have it go out at the same rate. So it's going out at the same rate. So it's going out at 10 liters per minute. Now we saw last time that when we do this, it becomes a separable DEQ, right? So we set it up by saying that Q of T is the kilograms of salt in the tank at time T. And dQ dt, the rate of change of salt, is rate in minus rate out. Now rate in is going to be what? It's going to be density. It's the density of the salt coming in times the fluid in. The fluid rate in. And the rate out is the density out times the fluid rate out. Rate here, fluid rate. Okay, so it's separable, yeah? So this is going to be what? 0.2 times 10, and this is going to be in kilograms per minute because the liters are going to cancel out. And what is the density out? That's the key to setting up the differential equation. What is the density out?
Wouldn't it have to be kilograms per liter, not kilograms per
Kilograms, yeah. Kilograms per liter, yeah.
No, up top. At the in density in.
Oh yeah, kilograms per liter, yeah.
In order for those units.
Right. So let's just do it. So it's 0.2 kilograms per liter times 10 liters per minute. That's right. And that's why we're getting a cancellation. Okay? And what about density out? That's the key to the differential equation. How much stuff is in the salt of salt is in there that's coming out in the tank? It's dissolved, but how much is totally in the tank? Q, right? It's Q. It's Q itself. That's where you get the differential equation. So there's going to be Q grams or kilograms, Q kilograms at a certain time, but the density is going to be divided by the 5,000 liters, which is never going to change because the fluid rate coming in is the fluid rate going out. So it's always just going to stay mixed. It's mixing, but it's staying at 5,000. So it's going to be Q over 5,000, and that's going to be in kilograms per liter. And then the fluid rate out again is the same. It's 10 liters per minute. And so these are going to cancel. And then this will cancel, and we'll get 500 there. Okay? And then here we'll get 0.2 times 10, so we'll just get 2. So we'll get 2 minus Q over 500. And that's really easy, right? So in other words, that's 1,000 minus Q over 500. And that's an easy separable differential equation. This is an easy separable differential equation. So the mixture problem, when it goes in at the same rate as it goes out, is a separable differential equation. So let's get this on both sides. So let's swing the dt over to the left-hand side, and let's move this over to the right-hand side. So we're going to have to integrate 1 over 1,000 minus q dq, and then we're going to integrate on this side 1 over 500 dt. Okay? So there it is. So we get t over 500 plus c is going to equal minus ln of 1,000 minus q, and then we'll move this over, so minus t over 500. Let's call the minus c a or something, plus a is equal to ln of 1,000 minus q. We'll do e to this, e to that, and we'll be on our way.
Why is it minus ln?
Chain rule.
Right.
Compensation. So for the chain rule. So this is going to be e to the a. We can rename that b. E to the minus t over 500. And this is going to be 1,000 minus q. And then we solve for q. So q is 1,000 minus b e to the minus t over 500. Yeah. Now, what's the initial condition? There was no salt initially in the tank. So, in other words, q of 0 is 0. So what is that? If q of 0 is 0, what does that make b? What is b if q of 0 is 0? 1,000. Yeah, because e to the 0 is 1. So this would have to be 1,000 minus 1,000 e to the minus t over 500. So that would be your solution. So after, let's see, so after 20 minutes, how much salt is in the tank? We're doing this in minutes, we just plug in 20. So it would be 1,000 minus 1,000 e to the minus 20 over 500. Anyone want to tell me what that is? I'll just get a sense of how much salt is in the tank after 20 minutes. What's e to the minus 2 over 50 or 1 over 25? What is it? 39 for the whole thing? Okay, so 39 kilograms. We're in kilograms.